Hey students, this is Mr. Boyd. In today's lesson, we're going to learn the difference between rational numbers and irrational numbers. So at the end of today's lesson, you should be able to identify a number as either being a rational number or an irrational number. Now, if you got a copy of these pages, feel free to color these pictures and make it your own. So what do these types of problems look like when you're asked to work them out on a piece of paper or on a test? Well, you're going to be asked to classify each number. Now, classify means to put numbers in groups or into buckets. So you're going to be asked if -7 is a rational number or an irrational number. Is the number pi a rational number or an irrational number? 2/3. 1.3, repeating. Remember, this bar means repeating. Is it rational or is it irrational? Why do we need this? Well, it's important to know if a number is rational or irrational, because rational numbers have certain properties and irrational numbers have different properties. Okay, so let's identify the different types of numbers to start with. So number one, what is a real number? Well, a real number is any number on a number line, or that can be written on a number line. For instance, -7, the square root of 3, -1.3 repeating, 0.2, 2/3, so on and so forth. Okay, what are rational numbers? Rational numbers are any number that can be written as a fraction. Okay, so that would be like 2/3. It's already a fraction. The number -3 can be written as -3/1. 0.2 repeating can be written as the fraction 2/9, so on and so forth. 1.5 can be written as the fraction 3/2. Okay, so what are integers? Integers are positive and negative whole numbers. So there's no fractions, no decimals in the integer group. It also includes the number 0. Sometimes you see it written like this. 3 dots, meaning it continues. -2, -1, 0, 1, 2, dot, 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 and then another little squiggle there. Okay? So that could be numbers like -3, -5, 0, 1, 2, 3, and so on. So let's define what a whole number is. Whole numbers actually begin with the number 0. That's the smallest whole number, and it continues on up using only whole numbers. No decimals, no fractions, so on and so forth. How about the counting numbers? Counting numbers actually leave out the number 0 and just start with the number 1, 2, 3, and so on. Now, sometimes the counting numbers are also called the natural numbers. Now, one thing I want you to notice is that each group is inside itself. So we got the counting numbers as the smallest group. Then we add 0, we get the whole numbers. Then when we add negative numbers, the opposites of the counting numbers, we get the integers. And then when we put in decimals and fractions, we get rational numbers. And then when we include irrational numbers cannot be written as fractions. So that includes the number pi. That includes 0.121121112. Okay, so what does it mean when let's go up here to the top of this next page. What does it mean if someone is rational? Well, that means that the things they do make sense. What does it mean if someone's acting irrational? They don't make sense. Or in some cases, we even say, man, they're weird. Okay? What are some common examples of irrational numbers? Well, common examples of irrational numbers would be like the square root of 3, the square root of 2, pi. All of those are common examples of irrational numbers. Now, it's important to note that an irrational number has a decimal that does not stop, and notice it doesn't repeat. This is not 1, 2, 1, 2, 1, 2. This is 1, 2, 1, 1, 2, 1, 1, 1, 2. Whereas back up here with rational numbers, they include repeating decimals. And in a previous lesson, we learned how to write repeating decimals as fractions. Okay? So let's move on down here. Practice number 1. Rational or irrational? Well, this one, the square root of 121, as we saw in a previous lesson, is the answer 11, or negative 11. Well, since that's a whole number that can be written as a fraction, this would be a rational number. Now, when we take the square root of 5, we end up with 2 point some crazy long decimal that never repeats. That makes this a irrational number. So for irrational numbers, you have decimals that do not repeat. Okay, let's look at this last example. Okay, I see I've got a decimal, and the 12 repeats over here, right? See, it's 0.712. If we continued this out, it would be 1, 2, 1, 2, 1, 2, and so on. This is a repeating decimal, therefore this is a rational number. Okay, I want you guys to pause the video and take a look at these numbers right here and determine, are they rational or irrational? Which of the following numbers are irrational? Okay, so let's pause the video and see and then turn it back on and see. All right, guys, welcome back. How'd you do? So if you followed along, irrational numbers, if we take the square root of 5, we end up with some crazy decimal. That's going to be irrational. Negative 4.2. That actually is a repeating decimal because after the 2 we have zeros that repeat. That's not an irrational number. That's a rational number. If we take the square root of 2, we get some crazy decimal. Okay? 7. 7 is a rational number because it's a whole number. As a whole number, it can be written as a fraction just simply by putting it over 1. And then pi, of course, that's the one special irrational number that we always see. So decimals that are irrational um, don't repeat and don't stop. Decimals that are rational either repeat or stop. These are called repeating decimals, and when they stop, they're called terminating. Okay? All right, let's classify the following as rational or irrational. So if we take the square root of 3, we end up with this crazy decimal. So this would be an irrational number. It has a decimal that does not repeat and does not terminate, does not stop. 1/5. Well, 1/5 is already written as a fraction, so this must be a rational number. How about this one? 0.26 repeating. That's right. It's a repeating decimal, therefore it has to be a rational number. How about pi? There's that special irrational number that we always get checked on, and it's irrational because the decimal does not stop and does not repeat. Which of the following numbers are irrational? This looks like the same set of numbers. Okay, so that concludes this lesson, guys. If you enjoyed this lesson, click the subscribe button. If you click the bell, then you will get notified when I put out new videos. Thanks. Have a good day.